Hey everyone, and welcome. Today we're jumping into a technology that is no joke, quietly changing our entire industrial world. It might not make the flashy headlines, but it's this invisible force that's keeping everything from factories to power plants, and yeah, even our data centers, running like clockwork. So let's get into it. The state of vibration monitoring here in 2025.
All right, let's start with a really simple idea. Just imagine for a second, what if your car could shoot you a text and say, hey, just a heads up, my engine's gonna fail next month. Think about that. You'd have all the time in the world to get it fixed, you'd avoid a huge breakdown, and you'd save a ton of money and stress. Well, that right there, in a nutshell, is exactly what vibration monitoring does, just on a massive industrial scale. It's all about predicting failure long before it ever happens.
So, you might be wondering, how does this magic actually work? Well, it all starts with this really powerful but simple idea. Every single machine has a voice. From the very second it's switched on, it creates its own unique vibration signature. And if we can just learn to listen to that voice, we can understand pretty much everything about its health.
And that brings us to the core of it all, vibration monitoring. It's literally the practice of listening to all those subtle shakes and rumbles. And why do we do that? Because vibration is one of the absolute earliest signs that something's about to go wrong. Things like a slight imbalance, a tiny misalignment, or a bearing starting to wear out, they all create their own distinct vibrational fingerprints. It's like forensics for machines. Those fingerprints tell us exactly what the problem is.
Now, why is this such a huge deal? Well, just take a look at the cost of getting it wrong. When a critical piece of machinery fails out of the blue, the consequences are, well, they're massive. You're not just looking at a big repair bill. You're dealing with lost production, you're missing deadlines, and you could be facing some really serious safety risks. This whole mess is exactly the problem that predictive monitoring is designed to completely wipe out.
This whole predictive approach is a fundamental shift in how we think. And to really appreciate it, you've got to understand that for decades, well, we handled maintenance in a totally different way. So let's take a quick look at that evolution.
So on one side, you have the old way. We call it reactive maintenance. And the philosophy was super simple. Fix it when it breaks. Just wait for the explosion, then clean up the mess. As you can imagine, this is incredibly inefficient and unbelievably expensive. But on the other side, you've got the modern approach, predictive maintenance, with a much smarter mantra. Fix it before it breaks. It's proactive, it's intelligent, and honestly, it changes the entire game.
And look, this shift didn't just happen overnight. It all started way back in the early 1900s with these big, clunky, mechanical recorders. But the real game changer, that came in the mid-1970s with the digital revolution and this incredibly powerful mathematical tool called the fast Fourier transform, or FFT. Okay, think of it like this. A machine's vibration is like a complex musical chord being played. The FFT allowed us, for the very first time, to digitally separate that chord back into all of its individual notes. And by isolating those specific frequencies, we could finally pinpoint specific problems. That's what laid the groundwork for the powerful AI-driven systems we have today.
And that brings us right up to today, because the state of vibration monitoring in 2025 is really being defined by this powerful 1-2 punch. First, the massive adoption of wireless sensors, and second, the intelligence of AI that makes sense of all the data those sensors are collecting.
Just to give you an idea of how big this shift is, the market for wireless vibration sensors, just the sensors alone, is projected to hit $1.5 billion this year. That is a huge number, and it tells you everything you need to know about where the industry is heading, away from cables and all in on the flexibility of wireless.
Okay, so what's really interesting here is the clear trade-off. For sure, wired systems are rock-solid reliable, but man, they are expensive and a total headache to install and scale up. Wireless systems are the complete opposite. They're simple to install, you can easily scale them across an entire factory floor, and they're way more cost-effective. So while wired systems still have their place for the absolute most critical machines, wireless is what's letting us monitor equipment on a scale we've just never seen before. So you've got all these wireless sensors out there, collecting mountains of data. What happens next? Well, this is where the AI works its magic. And the process is actually beautifully simple. Step 1. The sensors sense the vibrations. Step 2. The AI algorithms analyze all that data, and they find these tiny patterns a human being could never ever spot. And then, Step 3. The system tells you exactly what to act on by sending a clear, actionable alert right to your phone or computer. Sense, analyze, act. That's it.
And hey, this isn't just theory. Just look at this quote from a site leader over at Bega. He talks about the platform's ability to unlock the hidden potential in our existing data. And that right there is the key. So many companies are sitting on an absolute goldmine of data they've been collecting for years. And AI is the key that finally lets them tap into its value.
Okay, so we've got the tech, we understand how it works, but what does this actually look like out in the real world? Let's dive into the impact this is having across a bunch of different industries. And the impact? Well, it's everywhere. In manufacturing, it's preventing those costly assembly line shutdowns. In the oil and gas industry, it's making sure remote and hazardous equipment is safe. For power generation, it's literally helping keep the lights on for all of us. And in fields like aerospace and data centers, where failure is simply not an option, this technology is becoming absolutely essential.
And the results? They are just staggering. I mean, this isn't some tiny incremental improvement. Companies that put these predictive systems in place are reporting a potential 70 to 75% decrease in machine breakdowns. Just let that sink in. That's not an improvement, that's a complete transformation of how a business operates.
So, if this is where we are in 2025, it begs the question, what's next? Well, the future is pointing towards systems that aren't just predictive, but are becoming more and more autonomous.
One of the most exciting frontiers has to be the digital twin. Imagine creating a perfect one-to-one virtual replica of a physical machine that lives inside a computer. You can feed it real-time data from its physical twin, you can simulate different stress scenarios, and you can predict outcomes with unbelievable accuracy. It's basically like having a crystal ball for your most important equipment.
Next up is something called edge computing. So, instead of sending all that raw vibration data up to the cloud to be analyzed, what if the sensor itself could do the initial thinking? That's edge computing. It means you get faster decisions, you put way less strain on your network, and you get real-time responses for those critical machines where every single millisecond counts.
And this is basically the holy grail of wireless monitoring, self-powered sensors. Imagine a sensor that can harvest tiny amounts of energy from the machine's own vibrations or the heat it gives off. You could install it and literally just forget about it. No battery changes ever. This completely removes the last major roadblock to putting a sensor on absolutely everything.
So, that really brings us to our final thought. We're moving from a world where we just react to problems to a world where our machines can accurately predict their own future. And the question we're left with is, when that happens, how does all of that intelligence ultimately change ours? It's a pretty exciting future to think about. Thanks so much for watching.